I find that students have some kind of internal beef against trig functions, so I'm happy to write this video. Hopefully you'll be able to overcome whatever it is that deeply disturbs you about trig functions. To find extreme of the function, we need to find the critical points, and that's where the first derivative is 0 or undefined. And the derivative of sine is cosine. Argument stays the same, and we have to multiply by the derivative of the argument on account of the chain rule. So we care where this equals 0 or where the first derivative does not exist. You'll notice that cosine is a continuous function, so it's always defined, and so we can kind of throw out this idea, but we do have to find where it equals 0. 2 times the cosine of 2x equals 0 when the cosine of 2x equals 0, and 2x is the argument. So maybe think about this as the question, where does the cosine of theta equal 0? And perhaps you draw your reference circle here and think about cosine of theta as the x value, and x is 0 here at pi over 2 and down here at 3 pi over 2. So this green equation, cosine of theta equals 0, when 0 is pi over 2, or 3 pi over 2, or negative pi over 2, or 5 pi over 2, or any integer multiple of these pi over 2, odd integer multiples of these pi over 2 values for theta. Now we don't have theta as an argument, we have 2x, so 2x equals to theta to pi over 2, or 3 pi over 2. So that means that 2x equals pi over 2, or 3 pi over 2, or negative pi over 2, or 5 pi over 2, or any of these pi over 2's, right? But we want to find just the value for x, so we will divide both sides by 2. That means all these values get divided by 2 or multiplied by 1/2. So what kind of values do we get for just x? That's pi over 2 over 2, pi over 4, 3 pi over 4, negative pi over 4, 5 pi over 4. The next guy would be, who else? 5 pi over 2, 7 pi over 2, so 7 pi over 4. Then we would go to 9 pi over 2, or 9 pi over 4 when we multiply by 2, and that gives us all the integer multiples that are solutions to this equation. Now we really only care about the ones who are on the interval 0 to pi. So 0 to pi goes like this, and we want any values of x that are between 0 and pi. So pi over 4 counts, and 3 pi over 4 counts, but negative pi over 4 is out, and 5 pi over 4 is more than pi, and 7 pi over 4 is more than pi, and 9 pi over 4 is also more than pi. So we have these two critical values, 3 pi's over 4 and pi over 4. Pi over 4, 3 pi over 4. Now those guys are critical points of the function, so remember the second step was to divide the interval, and this interval is just 0 to pi, up by these critical points of the first derivative. So those critical points are pi over 4 and 3 pi over 4. Now we're going to test the first derivative, and the first derivative was 2 times the cosine of 2x. We'll test that guy on each interval here created, 0 to pi over 4 to 3 pi over 4, 3 pi over 4 to pi. So let's take this first interval. We have to choose some point between 0 and pi over 4, and the only value I know that I like from 0 to pi over 4 is pi over 6. So the first derivative at pi over 6 is 2 times the cosine of 2 times pi over 6. Well, that's 2 times the cosine of pi over 3. And the cosine of pi over 3 is positive. That's really all I care about. You could spend a lot of time worrying about exactly what that value is, which is 1/2 times 2 is 1. But pi over 3 happens right here, right? And so that's a positive x value, and the positive value for the first derivative, meaning that the function is increasing on this interval. Now between pi over 4 and 3 pi over 4 we have a great option, that's pi over 2. So if I test f prime at pi over 2, 2 times the cosine of 2 times pi over 2 is also known as 2 times the cosine of pi. And the cosine of pi is -1. Pi is right here. So that's 2 times -1, which is -2, also known as negative, most importantly, meaning that the function is decreasing on this interval. And then I have to choose a value between 3 pi over 4 and pi. Test that in the first derivative. So really the best choice we have here is 5 pi over 6, right? That value is right here. It's the over 6 is almost all the way to pi, but past 3 pi over 4 and not past pi. So that's twice the cosine of 2 times 5 pi over 6 from the first derivative, also known as 2 times cosine of 5 pi over 3. Oh my, 5 pi over 3. 5 pi over 3 is all the way over here, almost all the way to 2 pi, and those values of cosine are positive again. Positive a half, namely, but most importantly, positive. Positive, which means that the function is now increasing after 3 pi over 4. So we did step 2, we set up the intervals. Step 3, we tested the first derivative and had to tell us what we know. And step 4, we need to decide where are the extrema of the functions. At pi over 4 there's a maximum because we're increasing and then decreasing, and at 3 pi over 4 we have a minimum. Even more important than that is the fact that at 0, the endpoint, we have a minimum. That's because we start at 0 and then the function increases, right? That's what the first derivative told us. So 0 must be the low point on that end of the function. And on the right end point at pi, we have a maximum. That's because we're increasing to that as we approach the x value of pi. So pi must be the tallest of all the stuff around it on this closed interval. So now you have a bunch of relative maximums. Those are happening when x equals pi over 4 and pi. And we have some relative minimums at x equals 0 and 3 pi over 4. But in order to determine which one is absolute, we have to evaluate the function, the original function at these points. So that means we take f of x, which is the sine of 2x, and plug in these values to determine which one is largest. So for the maximum, let's see what happens at f of pi over 4. That's the sine of 2 times pi over 4, which is the sine of pi over 2, which is 1. And at pi, we have the sine of 2 pi, which is 0. So which one's larger? Pi over 4, right? So there's an absolute maximum of, the value is 1, and that happens at x equals pi over 4. So we might say, and I like this notation, pi over 4, 1 is the absolute maximum value. Alternatively, to find the minimum, we have to line up all those minimum values and see which one's biggest. F of 0 is the sine of 2 times 0, which is the sine of 0, which is 0. And f of 3 pi over 4, the other relative minimum, is the sine of 2 times 3 pi over 4, which is the sine of pi over 2. 3 pi's over 2, excuse me, and that is -1. So the guy who is smallest, an absolute minimum, is the smallest value, -1. So we have an absolute minimum of -1 at x equals 3 pi over 4. Or we can say the point, 3 pi over 4 for x, -1 for y. Now we've analyzed our function. If you need increasing, decreasing intervals, you can find that. I do suggest you follow step B and actually graph this. See how we can have a minimum at 0 and also a maximum at 0. These two things have exactly the same y value, but y is one a min and y is one a max. And if you make the sketch of the graph, you'll find out.